Hi Dr. Ang, tutors and fellow students. I'm Hakim of Group 2 and today I'm presenting our group's speech. So for our design project, we chose a brief 6 which involves shipping containers. So to give background, shipping containers are extremely crucial in this day and age because we buy a lot of stuff online. Thus, there must be a need for it to be transported and one more cost efficient and faster strategies is by container shipping. 90% of your products bought online are transported by container shipping. Hence, this is extremely important as the issues of such a industry will be felt throughout the world if something happens, and it's a very lucrative industry as one of the companies generated revenue up to 39 billion USD. So the problem of our brief is to design a product to reduce or prevent containers from falling overboard. The consequences of such a problem include supply chain disruption. For example, the APL container loss off the coast of Newcastle caused the manufacturer a lot of pain as 2,000 masks and ventilators were lost on board that ship itself. And to this day, the contents can still be found on the beaches of Newcastle and Sydney itself. Secondly, safety. Not only we're talking about the safety of the workers loading and maintaining the containers were on board the vessel. We're also talking about the safety of other ships because when a container falls overboard, it poses a single risk to smaller boats and might even sink them. The costly cleanup of these container spills are extremely costly, varying several million, and is very time consuming. Thus, a lot of companies have a vested interest to avoid this as much as possible. Statistics show that yes, as we pass with time, the containers generally are being lost less at sea. However, at 779 containers lost per year from 2017 to 2019, I believe we can do much better, and thus there's a vested interest in the industry to further curb this problem. So our solution is to make a reinforcement brace that will attach to the top of the container via double stack corner block, and the way so it will attach on the top, and as you see the protrusion on the side, the arrow and the arrow shaped hole will lock it in place and help increase rigidity between containers. The way it's going to be attached is that it will just slide into it from the top to the bottom. We further improve this design by changing the locking mechanism shape from an arrow to a T, as firstly we believe it's easier to manufacture, as making it easier to manufacture will reduce the cost of the entire product itself. Secondly, we believe that we can reduce the stress concentration, as such a shape, an arrow shape, will have high stress concentration at the edge itself, and thus we believe it might have a longer durability and shelf life when compared to the first design. So the advantages to our solution: first, less assembly needed due to the simple fact that it's just attaching to the top of a container and then just take it and slide it into the hole itself of another accommodating brace. Thus, there's not much assembly needed as everything is mostly down on the ground. Safer because there's less people need to be on top of the containers to check whether these containers are reinforced correctly. Thus, reducing the chances of people causing incident while on top of the container. Thirdly, simple to learn because it's a very simple mechanism as you're just attaching it to the top of the container. Hence, really it'll be simple to learn as you only need two things to make sure of how to attach the brace to the container and making sure it is properly attached. Cheaper because there's not a lot of parts, so the overall cost of manufacturing this brace will be cheaper. Thus, easier to maintain as there's not a lot of parts itself. Thus, we believe that it will be easier to check for defects. Furthermore, the final design will have a very shiny finish, so we can tell whether there are cracks and chips, hence a need to replace it. We further improve our design by making the lockable T-shape detachable, thus enabling us to save time if we have to throw out the whole thing. We are the final manufacturing design and adapting our design to be manufactured. Our material is made of aluminium T1009 T6 as is high corrosion as is in seawater conditions, and thus we need a high corrosion and it will be sandcasted to reduce time and money. This is my pitch. Thank you for listening.